So now we're going to look at a concept we call molar mass, which is something that we're going to use a whole lot throughout the rest of the semester. And if you take 12-12 with me, you'll also use it in the second semester of general chemistry. There we go. By listing how many atoms of each type of a molecule, the chemical formula contains important information about the mass of the molecule. So if we know how many atoms there are, we can figure out how much the molecule has to weigh. So molecular mass is the mass of 1 mole of that compound. So to determine the molecular mass, we're going to add the different atomic masses of all the atoms together. So let's look at an example. Carbon dioxide, CO2. One carbon atom has a mass of 12.01 grams per mole. There are also 2 oxygen atoms in this molecule, and each of those has a mass of 16 grams per mole. So if we add them together, we get 1 times 12.01 plus 2 times 16. We add this together, and we can find that the mass of carbon dioxide is 44.01 grams per mole. This calculation means that 1 mole of carbon dioxide has a mass of 44.01 grams. That provides us, just like with the when we were doing atomic masses, this provides us a conversion factor, where 44.01 grams equals a mole. I want to mention this also does mean that 1 molecule of CO2 has a mass of 44.01 AMUs. We don't use AMUs as often because we tend to talk about large quantities, but I don't want you to forget that a gram per mole for a molecule is also its mass in AMUs. So now, let's do some practice with this. I want you to try doing this conversion. So I know we haven't done one exactly like this yet, but start by trying to find the molar mass of C6H6, which we have practiced, and then apply the ideas of conversions from the previous chapter using atomic molar masses, but using this new number. Rather than 12 for carbon, you'll use whatever number you find here. So try finding your molar mass now. Okay, so let's take a look at this. So we know carbon has a mass of 12.01 grams per mole. Hydrogen is going to have a mass of 1.01 grams per mole. So we're going to multiply both these by 6 and add them together. So 12.01 times 6 is 72.06. And then we add to that 6.06 from the hydrogen, and we're going to get from adding these together that this molecule has a mass of 78.12 grams per mole. Now we can use this to convert things. So let's look at that. I realize I sort of jumped ahead when I described this problem. I forgot I've got another problem coming up where we're going to now use it as a conversion factor. So I'll show you how to do that. So let's use this molar mass. So the molar mass tells you how many grams there are in 1 mole of a substance. So let's do that. So we found out glucose has a molar mass of 78.12 grams per mole. So I'm going to show you how I could use that to determine the mass of 3 moles. So if I have 3 moles of C6H6, what I know is for every 1 mole, it has a mass of 78.12 grams. So if I multiply that by 3, and we only have 3 significant figures in our 3 moles of glucose, so this is going to be 234 grams of glucose, or C6H6. So the idea is this makes our conversion factor. Remember, you could also invert it, so you could put grams on bottom and moles on top if the conversion needed that. So for example, if you started out with grams, like we will in this next problem. So I want you to try this. Let's say you have sodium chloride, and you know you have 35 grams. How many moles are there? So pause me and give it a try. So now we take a look at this. So first we have to find the molar mass of sodium chloride before we move on. Sodium has a mass of 22.99 grams per mole. Chlorine has a mass of 35.45. And I'll write that down. I was busy looking at my periodic table on my book that's like below my desk, and I was trying to see it, so I wasn't writing. So this is 22.99 grams per mole for sodium plus 35.45 grams per mole for chlorine. So this is my sodium. This is my chlorine. We add those up, we get 58.44 grams per mole. So now we have 35 grams of NaCl, and we know that its molar mass is that for every 58.44 grams, we get 1 mole. So now we need to take 35 and divide it by 58.44, and we should have 3 significant figures. So you'll get 0.599 moles of NaCl. Now, I want to point out this step right here, where I wrote out what I was adding together, Once you get the hang of it, you can stop writing that down explicitly. Now, when you're first doing it, I recommend writing out that steps. You will probably find a molar mass multiple times for every quiz for the rest of the semester. There will be chapters where I would not be surprised if you had to find a molar mass 10, 12, 15 times on a quiz. The reason for this is you maybe work with multiple molecules, and every molecule you'll probably need to know the molar mass for. This is something you will do enough that eventually I hope it becomes second nature. Once you're comfortable with it, you don't need to write out the separate work for it. Just add it up on your calculator and move on. If nothing else, for purely practical purposes, of problems take a long time, and every step you write out takes a while. I do suggest that you do still write down something like this step, though, because it helps see where a mistake might be made if you're trying to get help on something. See, oh, where did I run into problems? Now, let's look at some more of what we can do. We can also convert to molecules. So as a reminder, 1 mole of substance is 6.022 times 10 to the 23rd. So I want you to try converting 12.5 grams of water to water molecules. If you're unsure how to get all the way to molecules, at least try to get to moles. But I'd like you to try the whole thing. But if you're unsure, at least get to moles. So pause me and give it a try. Now, let's take a look. We have 12.05 grams of water. We know the molar mass of water is, let's check. That is, once we add them all together, we get 18.02 grams per 1 mole of water. So step 1 is the same as the last problem. Now we've got to go back to one of our previous chapters, and we note that 1 mole of water is 6.022 times 10 to the 23rd water molecules. So therefore, we do this. So we have 12.05, we divide it by 18.02, and now we're going to multiply it by 6.022 times 10 to the 23rd, and we're going to get that this sample of water has 3 sig figs, 4.03 times 10 to the 23rd water molecules. So that's how you can use this information to find out how many water molecules you're working with. So now let's look at one more idea here. Let's look at mass percent. So we'll finish up this video with this idea. So mass percent for understanding how compositions work. So the chemical formula tells us the ratio between the different atoms in a molecule. However, sometimes what we want to know is the ratio of those masses of the different parts of the molecule. So to determine this, we use the following formula. Percent mass of some element X is such that you take the mass of that element in the compound divided by the mass of 1 mole of the entire compound and multiply it times 100%. Please note if there are multiple atoms of the same type, include the mass of all of them in the equation. So for a somewhat simplified version, if you were thinking at the molecule CO2 and you wanted to know the mass percent of oxygen, the numerator would be 32.00 grams per mole, because it's going to be how much both oxygens weigh, not just one, whereas in the bottom will be the mass of this whole thing. So that'll be 1632 plus that is 44.01 grams per mole. So make sure for the top part you include all of the elements and not just one of them. So, and I had this as the example problem we were going to solve. I thought I had a different example. So we take 32, divide it by 44.01, and then multiply by 100%. So let's see what that gives us. 32 divided by 44.01 times 100% will give us 77.7%. Note, 72.7%, not 77. This problem did not have a specific number of sig figs you would have to provide. So if you weren't told you could pick anything, I would ask that please give me at least a decimal to the 10th. Don't tell me the answer is 70%. And if you told me 72.71, that would be fine. I would have been fine with 73. If you tell me the answer is 72.71074.756, that's probably a little bit unnecessary. But unless you're told or given some other information, this one didn't have something that would limit you. So I would be fine with multiple answers, just give enough information. So now I want you to try a problem. What is the mass percent of hydrogen and water? So pause me and give it a try. And now we will take a look at this. So we want to know our percent hydrogen. So first we have to get the mass of just the hydrogen. That's 2.02 grams per mole. And then we have the molecule overall, which is going to be 18.02 grams per mole. Multiply that by 100%. And we have 2.202 divided by 18.02. And we're going to get that this is 11.2%, is the percentage of the mass that is made up of hydrogen. So that'll finish up for this section. In the next video, we're going to work through using chemical formulas as conversion factors for number of atoms, as well as a lot of stuff about the empirical formula and how we find that based on being able to, on research data.